No, no, but I'll have to be in it. You can at least sit behind the screen and people might go, I wonder if that's Hallie. Or they might not. Alright, who's got some working out to show me?
What'd you say? I wasn't listening.
Who's got some working out to show us? You're just sitting around doing nothing. Alright, well talk me through. What would you have to do to work out how many solutions there are?
Divide the one that equals 24 by 2 so that it has the same gradient and y equals 3.
Sorry, start again. Divide it by 2. 4x plus 6y equals 24. Divide the whole thing by 2.
And then you can see y equals the same and x equals the same.
So hold on, it'll be 2x plus 3y equals 12. And then you were looking at the gradient of the other one, which was what? Oops. The gradient of the other one was 2 as well?
Yeah.
So what did that tell you?
It's going to be on the same angle, so it's going to be
Parallel.
So what gradients? Same, therefore, same angle, therefore, what did you say, no solutions?
no solution.
It said parallel. Oops. My shorthand for instead of writing solutions, I'll write sols. All right. So, what?
Has no sols.
No sols. Without a U though. So. All right. Everyone follow what Kane did?
Yeah.
Or thought? Process? Yes. Anyone beg to differ with that answer? Everyone agrees? Maybe? Alright, so there are 2 cases on the right-hand side where there's parallel lines. The top one has no solutions. You can clearly see there are 2 different lines there with the same angle because they're parallel. Yeah? The bottom one has infinite solutions. Has anyone seen that before? Pardon?
Yeah.
Yeah? No? Right, what do you notice about them? Can you see the 2 lines down the bottom there?
Yes.
What colours are they?
Red.
Blue and red. One's dotted so you can see the other one below it, right? Blue and red. This might seem like pedantic, but they are 2 different lines. They just graph in the same spot. Alright? So, because the red line is directly on top of the blue line, it's always touching the blue line, isn't it?
Yeah.
When we solve things simultaneously, we were looking for an intersection point. So this is what we generally have. These ones are always touching, and no matter how far you go. So that's why we say infinite solutions. It doesn't matter what value you choose for either line, they're always touching. These ones never touch. No solutions. Alright? These ones touch once and that's it. There's one solution. So this one, as Kane has identified, the gradients are the same. Yeah? So what else has Kane assumed from those 2 equations to say that this is the case? Why isn't it this one?
Y-intercepts are different.
Yeah, y-intercepts different.
Y-intercepts are different.
Yeah.
So Kane didn't reference those in his answer, did he?
No.
No. He went straight from the gradients being the same to therefore having no solutions. Right? So if you want to prove that there's no solutions or infinite solutions, you also have to look at the y-intercepts. So in this case, what are the y-intercepts? 12, are you sure?
Yes.
How sure?
Positive.
Okay, what form of an equation is this?
No. 4 and 2.
Divided.
What did you do?
Divide by 3.
Divide by 3. So there's a coefficient here of y. You can't read y-intercepts when it's a coefficient of y. So if you divide this one by 3, this one by 3, you get c equals 4 for the first one and c equals 2 for the second one. So now you can clearly say that the first equation has a y-intercept up here and the second equation has a y-intercept that's lower. They still have the same gradient, but that must mean that they're 2 parallel lines now that are apart, mustn't it? Yeah? Different y-intercepts. Make sense?
Yep.
Yeah? Good? Right, so what would I look for if I was to find infinite solutions? What would I expect to see in the y-intercepts?
Same.
Same. Alright, so what we can annotate here is we can say m1 equals m2, but actually no, I won't write the words, I'll write it in notation. C1 does not equal C2. Can you understand what I've written there?
Yeah.
No? What's the letter that takes the place of the y-intercept in the general form of an equation?
C.
C. And if I have two equations, I'll differentiate them by having C1 and C2. Alright, so for no solutions, the gradients have to be the same, but the y-intercepts have to be different, don't they? Yeah? What would you expect to see here if I was to write a statement like this for infinite solutions? What would you expect to see?
C1 equals C2.
C1 equals C2 and M1 equals M2. Yeah? What would you expect to see here?
Opposite.
Does it have to be opposite?
Well,
Just different.
Just different every time. Now this one may or may not happen, hey? We could have either case, couldn't we? So in this case, do we need to reference the y-intercept?
No.
Because the key factor is the gradient, isn't it? Yeah? So we can choose to leave that off. All we're looking for here is the gradients are different. If the gradients are different, there's going to be one solution in where they intersect. If they're the same at all, the lines are parallel, and then you go through your steps of finding the y-intercept. Any questions? Alright, so there are two pieces of information you must identify. First one is the gradient, second one is the y-intercept. Okay? Just like every other thing we've done with graphing, you must know the gradient and the y-intercept. Alright, so if you ask questions like this, you still have to show those two pieces of information to prove your answer. Okay? Where are we up to? Alright, so what about this one? Erase that. And so I've changed the two equations on the board.
yeah.
How many solutions?
Infinite. They're the same equation.
Hang on. Yes.
Yeah,
Don't
it's
worry.
the same.
Alright, so what's a good first step to prove this?
Divide by 2.
Divide both by 2?
No.
Y
The
equals
4x
4x plus 6y equals 12 divided by 2.
Divide that one by 2.
Yes.
Alright, 4x plus 6y equals 12. Divide that by 2, I end up with 2x plus 3y equals 6.
Yes.
Do I need to do any rearranging?
No.
Yes.
What am I looking to do now?
Yeah.
Fun grade.
Yeah, find the gradients. So I could rearrange, couldn't I?
Yes.
So I move the 2x across, equals 6 minus 2x. Then I divide by 3. So y equals
2.
I'll move the gradient to the right spot, or the generally accepted front spot. This one, do the same process. 3y equals minus 2x plus 6. You can see what's going to happen, can't you? Oops. Yeah? So rearranging is probably a good habit to get into because it clearly shows you the gradients are the same and the y-intercepts are the same. Alright? A lot of people went from this and compared it to that, didn't they? That was what you did. You looked for the same digits in the same spots and you matched them up. Yeah? If you do that when you have negatives and things, you know how easy it is to make mistakes with negatives? Alright? Chances are I can guarantee that someone will make a mistake doing that when they match up these values here. So can you get into the habit of rearranging both of them into that y equals form? Right, I know it's an extra step, some of them will be simple, but it's the safest way to do it. Right, so rearrange into y equals. Your question?
So with one equation you minus 2x.
So I divided by 2. This one I divided by 2 first,
Yeah.
because we noticed that 4 was double 2 and 6 was double 3 and 12 was double 6, so we halved it. Then I rearranged it to get y equals. Just so I could clearly see what the gradient was and the y-intercept of each equation. Alright?
Yeah, but you could have got the same equation both.
Without dividing by 2?
No, you could have just taken negative 2, put 2x on the other side,
Yep.
and then you'd end up with the same equation for both.
Yes. So I didn't have to do that step.
Yeah. No.
You could have. Is that what you were saying?
Don't worry.
So I put this 2x in.
I think Toby's saying you could have left them both in 2x plus 3y equals 6 to save in the same equation.
Yeah, that's what I know that people did that, but I wanted you to get into the habit of doing this so I can clearly see the M and the C. Alright, you can compare this and this, but it's very easy to make mistakes if you do that. So I don't want you to get into that habit. I don't want you to develop good habits of rearranging into y equals and then comparing gradients and C values. Alright? So once you've done that, you can write down something like this. You can say M1 equals M2, C1 equals C2. Oh, look at that. It's therefore infinite solutions, if you really wanted to be that anal. Otherwise, you could say they're the same line. They must be on top of each other, therefore infinite solutions. All right? Any questions? No? All right, so keep in mind these are the criteria you're trying to meet. Okay? Do you need to write anything down in your notes at this stage? Because I'm going to rub that off the board.
I just have one question.
One question.
Why is one of them -2 and the other one's +2?
No, one of them, they're both +2, but one of them has a very faint vertical line.
Okay.
Good question.
Because it was really annoying.
Yeah, it is really annoying. And the circle goes straight through the vertical line as well.
Yeah.
Yep. Keep in mind, if it's still filming, this will be up on Compass. Still filming.
Don't worry, guys.
Don't rub it off.
No,
I've got a
put
link.
it on YouTube.
I've got a link on Compass to a YouTube thing.
Oh, I was gonna say.
You go into resources on Compass, and there'll be a folder called videos.
You teaching us math.
Yeah.
Nice.
So spread the word.
Yeah.
You know, I need 1,000 followers. I want to make a income off this.
You mean subscribing?
Whatever you call them on YouTube. Who
How many
knows?
you got?
Huh?
How many you
I
got?
don't know, 4 or something.
Yeah, that's supposed to be.
I'm not, look, people don't know me yet.
Yeah.
Alright?
You've got a lot of confidence.
Well, you have to.
Is this like a takeoff YouTube?
Take off, would you? Come on, I'm going to have to cut that out now.
Wait, I can't see.
Can't see what?
Copyright. You can rub that side off.
Yeah, I'm going to leave this up here for the whole time.
That's what I was like, you can't rub that off.
No, because that's our reference.
Yeah.
Alrighty.
This is the key information. This is what you want to have in your books.
That's all I'm writing.
Yep, that's fine. Alright. So, right, I'm going to ask you to do something slightly different now.
Oh, we're not doing the exercise.
No, not yet. There's 2 other examples to go through.
I just wrote it in purple, and that's my colour for occasions.
Oh, damn. Throw the whole book out.
I'm going to
You've done it.
have to.
I always bring this.
She used the wrong colour.
Which way is it? That's one.
It hurts. It hurts a lot more than you would ever know.
I haven't done it yet in this book.
I don't.
I hate when you write with too many colors.
Alright, so,
Thank you. Now.
equation in purple on there. Y equals mx plus 2. Picture it in your head. Oh, try. It's a straight line.
Yeah.
It has a y-intercept of 2. Yeah? So it goes through there, y-intercept. Do we know the m value?
Nope.
No. So it could be this line, or this line, or this line, or this line, or this line,
It
or
could
this
be
line.
straight.
Could be.
Could be.
Right? We don't know. All we know is that the m value is a variable. Alright? So, the question is, when is or does this line have no solution? No, sorry, let's start with infinite solutions. No solutions. When would it have no solutions with this line?
And the gradient is 5.
Gradient is 5. Why?
Yes, it's the same gradient as the other one.
Same gradient,
Parallel.
but different y-intercepts. So if m equaled 5 in this one's already 5, so you would be looking then at the y-intercepts and you would see that c1 equals 2, c2 equals minus 3. Alright, so the 2 lines have the same gradient, but they have different y-intercepts. So therefore the 2 lines are parallel and there are no solutions. That's pretty straightforward, isn't it? If the gradients are the same, the y-intercepts are different, there are no solutions. Alright, so now question, when would it have one solution?
Gradients.
When the gradient's -1/5.
When the gradient's anything other than 5.
Okay, go on then. -1/5? Just -1/5. Is that the only
Because
possible value?
perpendicular.
As long as it's
Sorry.
Anything is anything but 5.
I'm doing this
looked at the
deliberately,
board.
yeah. All it says here is does not equal M2.
So when it's not 5.
Oh, I didn't see that.
Yeah.
Anything but 5.
Anything but 5. How do I write that?
You just write M does not equal 5.
Yeah, so you can just copy
Greater or
this.
less than 5.
So you could say M does not equal 5. Therefore, one solution. Can you see how many different lines there would be for that to be the case?
Yes.
All the only criteria is that it doesn't equal one particular number. And that's it. Yeah? I'm not expecting, and you are not expected to write down some possibilities for this.
Wait,
All
so
right?
it could be like 5.1,
I keep
5.00001.
M on the end.
Whatever you want. There is only one
Keep
particular
writing
number that it can't
instead of
equal.
million.
Every single other number is in the game.
Exactly, that means
Alright? So at no point are you required to write down a possible list of numbers for this to be the case. You wouldn't go, oh, -1 or 1 or 0. There's some options there. That limits your choice. If you write that, that means you're telling me that there are only 3 choices, and that's them.
I
Right?
really need to get it.
You must phrase it so that everything else is open for a solution. Okay? Make sense?
Yeah.
Yeah? Good. What happens if these two lines intersect at the point 522? What is the gradient of the purple line if it goes through that point there? How would you figure it out?
I can't simplify 20 over 5 with
20
Wait,
over
what
5.
are we doing?
4?
Yeah.
No, my brain just wasn't thinking properly.
Wait, what are we doing this for?
So I want to know
Oh, the gradient.
if that's the point that these two lines intersect at, what is the gradient?
Of the first one?
Yep, we already know the second one, it's 5.
you use gradient point form, wouldn't
You could, yeah. Do we know the gradient?
you? Yeah. Oh, not that one.
We need to know this one.
Anything.
Wait, is 0?
Are you talking about using trial and error?
What are you talking about?
I want to find this.
Is it gradient?
That gradient.
That gradient. Have to find that because I know this line and this line both intersect at this point here.
Oh, so.
So 522 is here.
522 is where they intersect.
Yep.
And then is 0, 2 just a point?
So there's one there, and the other one is, I don't know where it is because
Just
I
a
don't know the
point on
gradient. Pardon?
Is it just a point on the line?
Yeah, well, that,
Where
where
two
they
points
intersect is
is
going to be a point on the
Ben
line.
knows the answer.
M equals 4.
It does equal 4. How'd you work
Ben,
it
I
out?
already worked that
How
out.
did you
Yeah, I worked it out as well also.
Good job. As
So
well
can
also.
you share what you did?
You substitute them in, so
Into what?
oh, well, we don't know what
Gradient point.
X. X and Y.
Where?
Oh, obviously.
What?
Okay.
In the equation.
Which equation? That one.
The first one.
This
Then equals yeah, that one.
Alright. So substituting in for x and y, so 22 equals
M times
5m plus 2.
Okay. Then you go subtract 2 from the end.
This is what you did, Annie.
Yep.
Oh.
So you get 20 equals 5m.
Oh yeah, that works.
And divide each side by 5.
Alrighty then.
And you're left with m equals 4.
Oh, who got confused here by looking at both equations and thinking you had to do something simultaneously and blah blah blah?
Yes.
I just got confused.
Yeah?
I don't know
I
what
just
got
got lost.
Alright, so this is why I've always asked you to picture something in your head. Okay? This is the intersection point here. 522. Alright? We know the equation of the second line. 5x minus 3, that's not even it because it doesn't have a right intersection. Goes more like that. Doesn't it? The other one we know goes through it. The y-intercept of 2. But that's all we know, other than it has to now go through that point there. We don't know the gradient. We're trying to find that gradient. aren't we? If you can picture this, you get an idea. Now, the next thing that goes through your head is, does this second line here, this one, does it have any bearing on this one's gradient now?
Huh?
No,
What?
It doesn't.
it doesn't.
All we know is it goes through that point. What's important here is the point that the first line goes through. Because we know that. If we're given 2 points, can we find gradient between 2 points?
Yes.
Yeah.
I did that.
So the only important information is to find the gradient between those 2 points if you want to do that. Or, shortcut is just to sub the point into the equation. Shortcut, I say shortcut because what you notice is that you know a y value, you know an x value, the only variable left is m. So if you sub a point in here, you automatically find m. Whereas if you do gradient between 2 points, you've got to deal with the whole formula. So horses for courses, you can do either way. You want to see me do the gradient between 2 points way? Yeah? So you know this one, 522, and this one, 0, 2.
Oh, and then you just do x.
So you'd have 22 minus 2 over 5 minus 0, which is 20 over 5,
Which is
which
the
is
same
4. Same thing.
I reckon that way.
I reckon blue squared off.
Up to you. Personally, I do this way. Because I'm worth finding the equation of the line. I'm interested in the equation of the line. But, up to you. Neither way is more correct. What matters is that you remember you're finding gradient, and so you use the appropriate formula. Alright? That's it. Okay? Alright, I'm going to skip ahead. No! You don't know what I've written next.
This is where I lose progress.
Just remember, these last 3 sets have been all about the gradient, haven't they? Yes, the most important thing is find the gradient. If you can do that, you've done most of the work for the question. This set is then about interpreting the gradient in different contexts. Alright, so what does it mean up here, what does it mean here, and what does it mean there? So if you can find the gradient, that's your base skill. This is the added layer of knowledge for this set. Alright, that is it. Don't let the wording get to your head. Alright? So, next example. We'll do 2 equations. And so the 2 equations are there. They both go through the point 1, 3. So they intersect at the point 1, 3. Yeah? So, how would we find out what k is? How did you know?
What I did is I substituted the coordinates in. And then I moved the 1 across and it became 2.
K is 2. That's pretty simple. Knowledge is you know the point that the line goes through, so you can sub it in for the x and y values. Alright? How would you find m in that one? Same thing?
Yeah.
I'm not going to write the 1.
Then you need to move 4.
So you take 4 from it.
So it's negative 1.
Yeah? Alright, so the knowledge we're dealing with here is that if you know a point that the line goes through, you can find the unknown from the equation. Alright? So, here's a more complex example.
Oh.
I'll leave that one up. Yep.
Wait, what are we finding?
So we're finding m and k. M and k. So before you start, what do you notice about the variables in equation 1 compared to the variables in equation 2?
They're in brackets.
Yep, they're in brackets. What else?
The gradient of the first one is -2.
And there's different forms.
They're in different forms. Anything else?
The second one is divided by 2, which is y.
You can divide that one by 2 because of the y, yep. Anyone notice this one has both m and k and this one only has m?
Yeah.
Yeah? So which one do you think you'd start with?
Yeah.
First one.
First one, it's got one variable. So how are we going to do it?
You need to kill it. Leave the m minus 2.
Go back to something like this. What was the first thing we did in this case?
Substitute.
Substitute. What was the point that the line goes through?
Point?
What's the point?
2 and
2, 8. So I don't know what m is. There's my 8. No, that's my 2, isn't it? There's the 8. Double check that, is that right?
Yeah.
Yep. Expand. I just put it in there to make it very easily visible that it's multiplied by this bracket because some people forget that. 2m plus 4 equals 2. 2m equals minus 2. M equals minus 1. Substitute, simplify, 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 simplify. What now?
Wait, shouldn't you?
Sorry, go on.
That alright?
Okay.
Silly question.
Ask, if you don't understand, ask it.
I was better than that.
Alright, I'll come over and good. Right, so what now? Now I know M. What now?
Rearrange the second equation so make in terms of y.
Okay. What are we trying to find here?
Okay.
So,
And Y.
if K is already the subject, do I need to rearrange?
No. Oh, and
I
then
could.
rearrange at the end. Sorry.
Yeah, we could
So
do
you
that.
just substitute. So
Just
negative
substitute.
1 at the end.
Yep, so -1 bracket 2 plus 2 bracket 8 equals K. And simplify.
I'm so confused.
With what?
How do we know that those gradients are the same?
Are they the same?
I don't know, you just put a -1 in there.
Well, what variable is that?
M.
What variable is that?
M.
Are they the same M's?
I
Well,
don't
that makes the
know.
Do
one.
they have a different label? If they were different, they would look like this.
Oh.
If they're the same variable, they are the same number.
Exactly.
Unless you move to a different question. Right, see how these are all in one question? So these equations are linked at this intersection point here. So the assumption has to be that the m values are the same. Notice that the x and y values were the same at that point, because they both go through the 2, 8. Right, so if the variables are labelled the same way, they have to be the same variable, same number. Yeah.
Don't you need to divide the last one by 2 because it's 2y?
No, but I've already taken care of that here.
Mm.
It's just a straight substitution. All I know is that k equals 2 times whatever y is plus m times whatever x is. So you don't need to take care of that in this case because we're not trying to solve for y, we're trying to find k. Okay?
So you don't need to rearrange it.
No? So, I'll jump on that though, Toby.
No.
The question here, and what I asked you at the start was, what is m and what is k?
Mm.
So your final answer is m equals this and k equals that, which we have. If the question asked you to write the equation of each line after you'd found m and k, then you would rearrange. You would sub these numbers back into the equations and you would rearrange to y equals.
Yeah, okay.
Alright, but if the question just says find m, find k, we stop here.
So what is K supposed to represent?
Yeah, that's not
Just
what it
another variable.
was. Is it like?
What does it represent in this one?
C?
Part of the y-intercept, isn't it?
Yeah.
To find the actual y-intercept, it'd be k divided by 2, because it's 2y.
Oh, yeah.
Alright, so if you see, because C is always referred to as the y-intercept, we couldn't have put C there because you can't read that. From the information, C is not whatever that number is, it's divided by 2, and then it becomes C. So we have to use a different variable here to separate it from C, right? Because C is just the simplified form. All right? Any other questions about that one? Alright, so I'm going to leave this one up here. I'm going to erase this one here. Because now we're going to look at them in terms of this stuff. Alright, so actually I want to put the rest of this one here. Same two equations. Same two equations.
Sure.
Let me get
This is the last example.
Yep, last one. What would M have to be for there to be no solutions? What would M have to be
The same.
for there to be no solutions?
Anything, because M is the same on both equations.
Has to be the same, yeah?
M is already the same.
Well, it's the same. Do we know what it is?
M
If we know it's M, we could say it has to be M, couldn't we? But that wouldn't really help anybody.
Well, it doesn't matter what number it is.
No, it's the same two equations, but remember in the initial question they went through the same point? That's no longer there. It's just the same two equations.
So then it doesn't matter what number M is, it would still be.
Four?
Wait, hang on. So,
All I'm asking is, what would it have to be for there to be no solutions? Doesn't matter?
It has to be the same two numbers.
It has to be the same number, doesn't it?
Yeah.
Because we know that they have to be
M
parallel.
has to be double the other M because it's
Oh, 'cause it's
2y.
2y, yeah.
So this M
Oh,
is the same number. Well, how could we find it out? How could we work this out? I'm not going to ask you to just plug numbers in and test. What formula?
One of them.
Wait, what are we trying to... what's the-
I want to know what M equals for there to be no solutions.
I'll work this out. We start with the gradient intercept form.
What?
Okay.